everyone, welcome to the lecture on Laplace Transform. In this video, we are going to discuss what is Laplace Transform and the Laplace Transform of standard function. Laplace Transform of the standard function means these are the some standard functions 1 t raised to the power n, e raised to the power at, sine, cos, sine hyperbolic, cos hyperbolic और इन फॉर्मूलेस का हम व्हेन वी आर सॉल्विंग द एग्जांपल तो डायरेक्टली हम इसका यूज करते हैं दैट यू नो वेरी वेल. तो ये फॉर्मूलेस को कैसे एक्चुअली लैप्लास आता है ये अगर आपको क्लियर है तो यू कैन इजीली रिमेंबर दिस फॉर्मूलेस. फर्स्ट क्वेश्चन अराइजेस व्हाट इज लैप्लास ट्रांसफॉर्म. लैप्लास ट्रांसफॉर्म की डेफिनेशन सबको पता होगी, इंटीग्रेशन के फॉर्म में आपने यूज भी किया होगा. लैप्लास ट्रांसफॉर्म मीन्स क्या होता है. अगर आपके पास में ऐसा कुछ टर्म लिखा है, लेट सपोज आई विल राइट डी बाई डी एक्स ऑफ साइन एक्स. सो डी बाई डी एक्स मीन्स आपको ये पता है कि इट रिप्रेजेंट द डेरिवेटिव ऑफ दिस फंक्शन. तो यू आर राइटिंग डेरिवेटिव ऑफ साइन इज कॉस एक्स. तो क्या हुआ, आपने इधर लेफ्ट साइड में यू आर टेकिंग द फंक्शन एक्स एंड देयर आंसर we will get in new form, that is a cos x. So this is derivative is nothing but a transformation. So derivative denoted by capital D. This D transformation apply on the function, the result become a f dash of x. So derivative is one type of transformation which gives you the transformation of function, that is nothing but the another form, or that we can call it is a derivative f dash. Similarly, if I will write I of f of x, so I of f of x, so again it is representing the transformation. I is for integration. So that is a when we apply in I of f of x, so you will get the integration of the function. For example, if I will take integration of e raised to the power 5x dx, so here I am applying I on this function. So I am applying I transformation on the function e raised to the power 5x. So we will get the another form of this function, and it is a e raised to the power 5x divided by 5, and there is an integrating constant c also, but here for understanding we will consider if we are applying the I, that is a transformation integration on the function, so we will get the corresponding value of the function or in answer in another form. So integration, derivative, these are also a transformation. So this two transformation we are always use, and we know very well about this derivative integration. The similar way there is a Laplace is again a transformation. So what is a Laplace? This is a function or it is a transformation. L is a transforming the function f of t into the another form, that is capital F of s. That means when we apply this L on function f of t, so you will get the result in the form of capital F of s. That means here t variable we are transformed to the another variable s. अब ये कैसे होगा, तो for that we required a proper definition. So what is the L? L is a transformation, Laplace transformation on this function. So we will use the integration definition. But the simple meaning is we are transforming t variable into the s variable. Why we are doing this process? Because when there is a application based problem, for example solving differential equation, ordinary differential equation, so always सेपरेट वेरिएबल या फिर अदरवाइज जो हमारे सॉल्विंग डिफरेंशियल इक्वेशन के स्टैंडर्ड मेथड है वो कभी कभी एप्लीकेबल नहीं हो पाते हैं. और देर आर मेनी एप्लीकेशन इंजीनियरिंग प्रॉब्लम्स लाइक सॉल्विंग circuit problems, or there is a problems based on the containing the differential equation. तो उन्हें easily solve करने के लिए we can take the help of Laplace transform, because that example are not in our standard form of differential equation. So that's why we cannot solve easily by that regular method. So we take the help of Laplace transform that difficult problem into the simple problem. That means we are converting that t variable into s. After simplifying, you will get the simple form of f of s. Then we apply the inverse, because this inverse function f of t is called the inverse of f of s. So here f of t is nothing but what? It is nothing but the inverse of f of s. So once we get the simplified term of s, So we apply the Laplace inverse. So you will get the answer in the form of t. That is nothing but our solution of our problem. Definition of Laplace transform. So what is the definition of Laplace transform? So now see the definition of Laplace transform. So here let f of t be a function be a function of t be a function of t defined for defined for all positive values of t, then Laplace transform Laplace transform of f of t is denoted by here the notation to denote the Laplace transform f of t is L curly bracket f of t, and is defined by Laplace of f of t is equal to Laplace of f of t is equal to integration 0 to infinity e raised to e power minus st f of t dt. So this is the definition of our Laplace transform of function f of t. So see here if you observe this term, so Laplace of function we have to write integral function into e raised to e power minus st. Integral limit is 0 to infinity. So here we are taking t is a positive value. So t is positive, that means t we are taking greater than equals to 0. That's why our limit is 0 to infinity. There is a some two dimensional like minus infinity to infinity also, but throughout the chapter we are studying for 0 to infinity. That's why we are writing definition in the form of integral 0 to infinity. Now this f of t is a inverse Laplace transform of f of s. Here when we apply the Laplace transformation on function f of t, so this is nothing but this integration, and this answer, this integral 0 to infinity, if we integrate this term, so we are integrating with respect to t and put the limit, upper limit, lower limit in t. So you will get complete answer in the form of s. That's why we denote this term as a capital F of s, or in some books they are using the notation f of s bar. So either you can use f of s or this notation f of s bar. And this f of t is the inverse of f of s. That means f of t, this is the function, is the inverse Laplace transform of f of s. So using this definition, you have to derive this standard formulas. So let's see. The first one is Laplace transform of 1. So Laplace transform of 1, all formulae we derive with the help of simple definition of Laplace transform. So by definition of Laplace transform of f of t, it is integral 0 to infinity e raised to the power minus st into function f of t dt. Now, in this problem, we have to take f of t is 1. So, instead of f, if we write 1, so it is a e raised to the power minus st into 1 dt. And integration of e raised to the power minus st is e raised to the power minus st divided by minus s. Limit is 0 to infinity. And when we integrate with respect to t, the coefficient of t we have to take in denominator. So coefficient of t here it is minus s. Now here Next step, minus 1 upon s is constant, take outside. Put upper limit minus lower limit in t, because when we integrating with respect to t, that means we have to put upper limit, lower limit both in variable t. So if we put upper limit infinity, so it will become e raised to the power minus infinity minus of lower limit, that is e raised to the power 0, and e raised to the power minus infinity, e raised to the power minus infinity, it become a 0. If we take e raised to the power infinity, then it is not defined, but for minus infinity it is a 0. So here it is 1 upon minus 1 upon s as it is outside term, and bracket 0, and e raised to the power 0 is 1. So therefore, we get answer 1 upon s. So hence, Laplace transform of 1 is 1 upon s. So sometimes प्रॉब्लम सॉल्व करते वक्त यू में भी कंफ्यूजन होता है कि फॉर्मूला क्या है, तो शॉर्ट में आप डिराइव कर सकते हैं बाय डेफिनेशन ऑफ लाप्लास ट्रांसफॉर्म, और उसमें यूज कर सकते हैं. तो एग्जाम में कंफ्यूजन अगर होता है, फॉर्मूला याद नहीं आता है, यू कैन डिराइव बाय दिस डेफिनेशन. नाउ द नेक्स्ट वन इज लाप्लास ट्रांसफॉर्मेशन of e raised to the power at. E raised to the power at, again use the simple definition. So by definition of Laplace transform on function f of t is nothing but an integral 0 to infinity e raised to the power minus st into f of t dt. Here our function is e raised to the power at. So therefore integral 0 to infinity e raised to the power minus st, and put the value of function. So here our function is e raised to the power 80 dt. Now both term contain the power of e, and we know that a raised to the power m multiplied by a raised to the power n. So here base term is same, so we can add their powers. So we write m plus n. Using this concept, here integral 0 to infinity e raised to the power minus st plus at into dt. So here I am taking the addition of their power. Now in the next step, here the next step is important. In the power, you have to take the common term outside, and as well as see here I will take minus sign also out. That is e raised to the power, I will write minus in bracket s minus a t dt. Why we are writing this term? Because e raised to the power minus infinity, we know that minus infinity it gives the answer 0. So for understanding, we will get here minus sign out, so that when we put upper limit minus lower limit, you will get the answer here 0. Now here e raised to the power integration of e raised to the power ax, here integration of e raised to the power ax is nothing but e raised to the power ax upon a. So here integration of this term is e raised to the power minus s minus a t divided by coefficient of t is minus s minus a, and limit 0 to infinity. Now when we put upper limit, lower limit, so whatever remaining term constant we can take outside. So this denominator does not contain t, so I will take minus 1 upon s minus a outside, and here put upper limit. So integration we are taking with respect to t, to put upper limit minus lower limit in t. So here t is infinity, so e raised to the power minus infinity minus e raised to the power 0. So here this is 0 and this one is minus 1. So ultimately it is a 1 upon s minus a. Hence Laplace transform of e raised to the power at is 1 upon s minus a. And using this formula we can write the third formula also. Here Laplace of e raised to the power at is 1 upon s minus a by our second formula. So here e raised to the power, if it is a 80, so we get 1 upon s minus a. A is what? A is a constant. So if a is any constant, so replace that a by minus a. A is any constant. A is 4, 5, 6, anything. So instead of positive a, if I will write minus a, so it is a e raised to the power minus 80. Replace throughout a by minus a to here in 1 upon s plus a. So right side become 1 upon s plus a. So when the power of e is positive, so we have to subtract a from s, and if the power is negative, so we have to write it is a s plus a. For example, let's suppose that we have given the question Laplace transformation you have to find e raised to the power 5t plus e raised to the power minus 2t. So here we can write it is a Laplace of e raised to the power 5t plus Laplace transform of e raised to the power minus 2t. And here this term contain positive power. So here Laplace of this term is 1 upon s minus 5, and this power is negative, so we can use 1 upon s plus 2. So here we get the answer of our problem. Now next formula is Laplace transformation of t. Again, by definition of Laplace transformation, here if there is a function of t in a Laplace, so it is an integral 0 to infinity e raised to the power minus st f of t t. All the standard functions we are solving by simple definition of Laplace transform. Now here Laplace of f of t, f of Laplace transformation of f of t. Here our function f of t is t, so that's why I am writing here t. So here f of t, if we take simply t, so Laplace transformation of f of t is equal to integral 0 to infinity e raised to the power minus st into t dt. Now to solve this integration, we have to use integration by parts formula. So what is the integration by parts? Integration of u v dx is u as it is. Integration of v, so I am taking derivative integration with respect to t. So I will write u integration of v minus integration of v derivative of u d. So this is the integration by parts formula. I will use it directly. See here how to write this term u as it is. So this is our u and e is our v. So u as it is integration of v. So this term we have to integrate. The e integration is e raised to the power minus st divided by minus s minus integration of, see here whatever integration answer we will get for v, that integration you have to write here. So integration of v is this one, so that we will get in integration divided by minus s. Derivative of u, the derivative of t with respect to t is 1 d. Now here t e raised to the power minus st divided by minus s as it is, and this minus of minus plus 1 upon s, again take the integration of e, so it is e raised to the power minus st upon minus s, and this whole term we get some now in the next step we have to put the upper limit minus of lower limit. So here in the next step, I will put the limit. Upper limit is infinity. If we put infinity, so e raised to the power, we know that e raised to the power minus infinity is 0. So just by observing the term, you will get the answer of this question. See here, when we put upper limit, so here it is a containing e raised to the power minus, and here also e raised to the power minus t. So that means for upper limit, both terms are 0. So upper limit, no need to put minus of lower limit. Lower limit is 0. So when we put t equals to 0, so see here this term contain t. So put t equals to 0, the multiplication contains 0. So that means this whole term becomes 0. Then next here also you have to put t equals to 0. So here t equals to 0, so you will get 1 upon s square. Because e raised to the power 0 is 1, remaining is 1 upon s square, and this minus sign. Now therefore, this minus of minus plus, so Laplace transform of t is 1 upon s square. Now the next formula is Laplace transformation of t raised to the power n. So here For to solve this Laplace transform of t raised to the power n, we have to use here beta gamma concept. So see here, Laplace transformation of f of t, by definition of Laplace, it is integral 0 to infinity e raised to the power minus st f of t dt. Here our function is t raised to the power n. So instead of f of t, I will write t raised to the power n. So it is e raised to the power minus st into t raised to the power n dt. And here I am using, here to solve this term I have to use gamma function, and definition of gamma function is gamma of n is integral 0 to infinity e raised to the power minus x raised to the power n minus 1 dx. So for that, here e raised to the power term must be in a single variable. We'll put st by x. So we put st equal to x. That means t is equals to x by s. So dt is 1 upon s dx. Corresponding limit also you have to change. Here it is a limit for t, and to convert it the limit for x. So it is again x is also varies from 0 to infinity. When we put t equals to 0, so you will get x 0. When we put t equal to infinity, so you will get x is also infinity. So that means limit of x is 0 to infinity. So therefore our integral Laplace of t raised to the power n equal to integral 0 to infinity e raised to the power minus x, and t is our x by s raised to the power n, dt is dx by s. Here dt is dx by s. Now when we integrating with respect to x, so s is constant, take that s quantity outside the integral. So it is s raised to the power n plus 1, remaining is integral 0 to infinity e raised to the power minus x raised to the power n dx. Now compare this integral with, so it is e raised to the power minus x raised to the power n. So here it is x raised to the power n minus 1. So for n minus 1 it is gamma n. So here this is a gamma n plus 1 divided by s raised to the power n plus 1. And gamma n plus 1, by property of gamma, it is a n factorial s raised to the power n plus 1. Hence the Laplace transform of t raised to the power n is n factorial upon s raised to the power n plus 1. So in this way, you will get a formula of t raised to the power n. Here, if we put t equal to 2, so you will get the formula. If we take n is 2, so you will get t raised to the power 2 is 2 factorial upon s raised to the power 3. That means 2 by s cube. So corresponding n just you have to put, so you will get the answer. And this is most important formula in Laplace transform. Now the next is Laplace transform of sine at and cos at. Sine and cos either you can write in the form of e and then solve. Here Laplace transformation of next formula is sine at. So by definition of Laplace transform, Laplace transformation of f of t is integral 0 to infinity e raised to the power minus st into f of t dt. Now, in this term, you have to solve the Laplace of sine function. So here, instead of f of t, I will write sine at. So by definition, it become integral 0 to infinity e raised to the power minus st into sine at dt. Integration का formula that is integral e raised to the power at into sine bt dt. It is e raised to the power at upon a square plus b square in bracket a sine bt minus b cos bt. So this is the standard formula of integration. If we apply for this term, so Laplace of sine at is e raised to the power minus st upon s square plus a square, because we have to take the coefficient of t square in bracket a means minus s sine at minus b is our a cos at. And next we have to put upper limit minus of lower limit. So for upper limit, here this e is in multiplication, so when we put upper limit infinity, so this whole term becomes 0. So for upper limit, this integral is 0 minus of lower limit. Now lower limit we have to put 0, so e raised to the power 0, here put t equals to 0, to this term e raised to the power 0 is 1 upon s square plus a square in bracket, here t is 0, sine of 0 is 0, so this first sine term is 0, cos of 0 is 1, so it is minus a. That means this minus a and this minus, that is a upon s square plus a square. And this is the formula of Laplace transform of sine at. So Laplace of sine at is a upon s square plus a square. This is the one method to solve Laplace transformation of sine at. Next is Laplace transformation of cos at. So again use the definition of Laplace transform. So by definition of Laplace transform, here Laplace of cos at is integral 0 to infinity e raised to the power minus st f of t, here function is cos at dt. And again, if we use the integration standard formula, e raised to the power at into cos bt is e raised to the power at upon a square plus b square. It is a cos bt plus b sin bt. So this is a standard formula of integration. Now here apply this formula. So Laplace of cos at equal to e raised to the power minus st upon s square plus a square. Just you have to compare this term. So s is our a and this b is nothing but our a. So here a, that is minus s cos at plus a sin at, and limit is 0 to infinity. Now again for upper limit, this whole term is 0 minus of lower limit. So lower limit is e raised to the power 0 is 1. So it is 1 upon s square plus a square. Now here also put upper limit, cos of 0 is 1. So minus s, and sine of 0 is 0. So if we simplify this term, so you will get s upon s square plus a square. So that is the formula for this cos at. So cos at is s upon s square plus a square. So in this way we have to derive this formula. Now the next is Laplace transformation of hyperbolic function. So instead of sine, simply if it is a sine hyperbolic at. So for sine hyperbolic at, here this hyperbolic function you can convert in the form of e. So here Laplace of sine hyperbolic at, if we write this sine in the form of e, then it is e raised to the power at minus e raised to the power minus at upon 2. Now, by definition, it is integral 0 to infinity e raised to the power minus st into function. So function is e raised to the power at minus e raised to the power minus at divided by 2 dt. In integration, constant we can take outside or term wise we can separate the integration. So 1 upon 2 is constant, take outside. Integral in 0 to infinity e raised to the power minus st e raised to the power at dt minus integral 0 to infinity e raised to the power minus st e raised to the power minus at dt. Now see here, this first term we have already solved, and if we apply the reverse definition of Laplace, so e multiplication is any term of t that is a function. तो ये यहाँ पे e raised to the power minus s t के साथ में ये जो टर्म है, this is our function. So रिवर्स में अगर definition of Laplace के फॉर्म में देखोगे तो this first integral is nothing but Laplace transform of e raised to the power at. And similarly, this second is a Laplace transform of e raised to the power minus 8. और दोनों टर्म का लैपलास हमने फर्स्ट और सेकंड फॉर्मूलेस में ऑलरेडी सॉल्व करके रखा है, तो उसी टर्म का अगर ये e raised to the power 80 और माइनस 80 इनके फॉर्मूलेस को डायरेक्टली यूज करते हैं, तो हियर 1 upon 2 first term is 1 upon s minus a minus second is s plus a. If the power of a is positive, then you have to write minus, and it is minus, then you have to write it is plus a. Cross multiply this term. So after cross multiplication, you will get s plus a minus s minus a upon s minus a into s plus a. Use the formula a plus b, a minus b in denominator, and in numerator here minus s plus s 0 and a minus of minus a. So this is the 2a. So here 1 upon 2 as it is. In numerator it is a 2a upon s square minus a square. So therefore the Laplace transform of sine hyperbolic at is a upon s square minus a square. Similarly, we have to solve for cos hyperbolic at. So here, the next is Laplace transform of cos hyperbolic at. Angle is 80. This is a hyperbolic function. So again, by definition of Laplace transform of f of t, it is integral 0 to infinity e raised to the power minus st f of t dt. Now put the value of function. So our function is cos hyperbolic at. So therefore it is integral 0 to infinity e raised to the power minus st cos hyperbolic at. Now this cos also you have to convert in the power of e. So there is a standard formula. So that formula if we use, so it is a e raised to the power at plus e raised to the power minus at upon 2. It is same as sine, just in sine hyperbolic it become a middle symbol is minus, in cos it is a plus. So therefore 1 upon 2 constant we can take outside and term wise integral separate. So integral 0 to infinity e raised to the power minus st e raised to the power at dt plus integral 0 to infinity e raised to the power minus st e raised to the power minus at dt. तो बस हमने यहाँ पे डेफिनेशन ऑफ लैप्लास यूज किया है. अब यहाँ पे भी हम अगर इस टर्म को ऑब्जर्व करते हैं तो इट इज ए लैप्लास ऑफ e raised to the power at. So that means here first term is a Laplace of e raised to the power at and second term is a Laplace of e raised to the power minus at. यूजिंग आवर स्टैंडर्ड फॉर्मूलेस, तो इन दोनों को हमने ऑलरेडी डिराइव करके रखा है. तो बाय दैट डेरिवेशन इट इज 1 अपॉन एस माइनस ए प्लस 1 अपॉन एस प्लस ए. क्रॉस मल्टीप्लाई दिस टर्म 1 upon 2 as it is. So after cross multiplication, here it is a s plus a plus s minus a divided by s square minus a square. तो numerator में देखो s we get 2s and a 0. So 2s and this division 2 get cancelled. So that means Laplace of cos hyperbolic at is s upon a square minus a square. Hence, we get the answer. सो आई होप दिस ऑल फॉर्मूलेज आर क्लियर टू यू। और अगर ये फॉर्मूलेज आपको समझ में आ गए हैं तो इन केस एग्जाम में याद नहीं आए फॉर्मूलेज तो आप इस तरह से डिराइव करके चेक कर सकते हो कि क्या एग्जैक्टली आ सकता है। और समटाइम्स अगर आपका बेसिक साइंस है तो उसमें डायरेक्टली फॉर्मूलेज डिराइव करने के लिए भी आते हैं। तो इस तरह से आपको फॉर्मूलेज प्रूव करना है। तो यहाँ पे कोई भी हमने प्रॉपर्टी यूज नहीं किया, जस्ट सिंपली बाय डेफिनेशन ऑफ लैप्लास हमने सारे फॉर्मूलेज को सॉल्व किया। ट्रांसफॉर्मेशन ऑफ साइन 80 is nothing but a upon s square plus a square, और Laplace transformation of cos 80 is s upon s square plus a square। अब ये है, आप इसको सॉल्व करके बताओ कि यही फॉर्मूला है करके। और ये सिमिलरली फॉर cos। तो इस linearity प्रॉपर्टी के लिए वी हैव टू राइट दिस साइन इन द फॉर्म ऑफ e, एंड दैट फॉर्मूला इज e raised to the power 80i minus e raised to the power minus 80i upon 2i. So this is the formula of sine theta. So sine theta in the form of e, we are writing in this form. So now linearity property says that 2i is constant, take outside. Laplace of first term minus Laplace of second term. Now here e, Laplace transformation of e is known. So using this term, it is a 1 अपॉन एस माइनस ए मीन्स टी के साथ में जो भी कांस्टेंट है दैट वी आर टू सबट्रैक्ट। तो टी को छोड़ के देखो पावर में क्या है, ए आई, सो दैट ए आई बिकम इन सब्ट्रैक्शन ऑफ एस। यहाँ पे टी को स्किप करोगे तो ये जो टर्म है इट इज एस माइनस ऑफ माइनस प्लस ए आई। नाउ क्रॉस मल्टीप्लाई दिस ब्रैकेट। तो अगर मैं क्रॉस मल्टीप्लाई करती हूँ तो ये कुछ ऐसे होगा, 1 अपॉन 2i ऑलरेडी इज देयर, क्रॉस मल्टीप्लिकेशन, so s plus ai minus s minus ai upon s minus ai multiplied by s plus ai। now here ये ब्रैकेट ओपन करके सिंप्लीफाई कीजिए तो s का सब्ट्रैक्शन हो जाएगा टर्म का, और 2i यहाँ पे आएगा बिकॉज ए आई माइनस ऑफ माइनस प्लस ए आई, सो दैट बिकम 2ai। तो 1 अपॉन 2i एज इट इज, and it is a 2ai upon first term square minus of second term square, a square minus b square का फॉर्मूला हम यूज कर रहे हैं। here 2 और डिवाइडेड में 2i, दिस न्यूमरेटर डिनोमिनेटर 2i गेट कैंसल, तो ये रिमेनिंग रहेगा a इन न्यूमरेटर, a स्क्वायर माइनस आई स्क्वायर इज माइनस 1 एंड a स्क्वायर a स्क्वायर। तो देखो यहाँ पे ए आई का स्क्वायर है और आई स्क्वायर वी नो दैट इट इज माइनस 1। नाउ इट इज माइनस माइनस बिकम प्लस, सो इट इज ए अपॉन ए स्क्वायर प्लस ए स्क्वायर। हिंस वी गेट द आंसर ऑफ लाप्लास ट्रांसफॉर्मेशन ऑफ साइन 80। तो ये ऐसे ही फॉर्मूला डिराइव होता है साइन 80 का, और वही से हम इसको कंटिन्यूशन में लेते हैं। तो बेसिक सिंपल जो फॉर्मूलेज है वो भी मैंने वीडियोस में ऑलरेडी डिस्कस किए हैं, तो आप ट्राई करके देखो कॉस 80 का करेक्ट फॉर्मूला आता है क्या।
Give, like, share, subscribe.